Okay, it's time to learn how to write equilibrium constant expressions. In this screencast, you'll learn how they are defined. They usually use the term KEQ, that is the equilibrium constant. And we'll see some of the most common errors that people make when they set it up because it's a fairly picky calculation. There's some things you just need to remember. This is screencast 14.2, and let's get started. Okay, how to write the equilibrium constant expression. Let's have a typical reaction here. A scientist would say we are hydrogenating iodine to make hydriodic acid. Or you could more simply say we're mixing some hydrogen with some iodide to make some HI, a nasty acid. For this, the equilibrium constant is always defined as the concentration of the products over the reactants. So it's going to be the concentration of HI. But notice that it's squared. Do you remember that? That's one of those things that's easy to forget. Coefficients become exponents. So this number will be squared, making it dramatically different, making it either higher or lower depending on what its value is. And that's divided by the concentration of the reactants, and they get multiplied by each other, and they're measured in moles per liter because they are in brackets there. That's the moles per liter, and that's how you do it. Let's go ahead and try another one. We're taking some iron oxide and reacting it with carbon monoxide to make some iron and some carbon dioxide. So it looks like iron is being reduced for those of you who want to look at it specifically, and carbon monoxide is being oxidized to carbon dioxide. I suppose this is a redox reaction. Okay, fine. And so when we do the same sort of analysis, the concentration of the products over the reactants, wait a minute, why isn't iron there and why isn't iron oxide on the bottom? Hopefully you've remembered to omit liquids and solids. Another of the rules for setting up this equilibrium constant expression. That means that we assume that means this stuff has precipitated out of solution, which it has here, or didn't get into solution in the first place, I suppose, but then it wouldn't react. In any event, we omit liquids and solids. That's how we write the equilibrium constant expression.